Hello all, today we are going to see about the linear regression analysis. So in this analysis, we understand the relationship between two or more variables. The relation is a linear relationship here. So when we have more than two variables, we call it as a multiple regression. So here, one of the variable, so let's say we are interested in only finding the relationship between two variables. So one variable is an independent variable, which is normally the input, and the other variable is a dependent variable, which is the output variable, which will be predicted from the input variable. So here, so how do we understand the relationship is that, so we'll see this graph. So let's take an example. Let's say we have two variables with us, that is x and y. So let's say we need to find the rent of a house. So the input variable is going to be the square feet of the houses, and so as the square feet increases, the rent also will increase. So there is a linear relationship between these two variables. So all we have is a few x and y pairs. Let's say I have 50 x and y pairs. So that is the square feet of the houses and its corresponding corresponding rent. So with this 50 xy pairs, what I need to do is that I need to predict the unknown x value. For example, I don't have the rent of 2500 square feet. So after this linear analysis, I will be able to substitute in this equation 2500 and then predict the output. So now we'll see how we can do this. So that is the overall goal. So we need to predict the unknown value of x and x and y. So that is the overall goal. We'll see how we will do this. So I said, like, I have already 50 xy value pair. So with this x and y pairs, so what do I do is that I plot the graph, and I will plot the graph and I will try to find the line which best fits the all the plots. So we cannot accommodate all the plots, but then we will try to find a straight line which fits most of the observations. And then finally, so that line is nothing but this equation. So y cap is equal to b0 plus b1x. So here b1 is the y-intercept and b1 is the slope. So now b1 is positive when x increases and y increases. The slope is going to be positive. There can be scenarios when x increases, y tends to decrease, then the line would be like this. So then there is a negative slope. Then the negative slope is nothing but when, for example, we'll see, we'll take this example. So let's say the x is nothing but the amount of time a student spends on a social network. So then y be the grade he obtains. So when more number of time a student spends time on social network, his grade would come down. So that is, there is a linear relationship, but there is a negative relationship between them. In that case, our b1 will be negative. So that's the idea. So to come across, and then we also need to, after finding the slope, we also need to understand the y-intercept. So we have formulas for that. So using that formula, we will find this line of best fit. So we will see how we will do that. So that procedure is called the least square method. We'll see with an example. For simplicity, let's say I have 5 observations, so 5 x and value pairs with me. So this is the formula. So we have x and y pairs with us. We need to find the slope b1 and y-intercept b0. So what is a y-intercept? Y-intercept is nothing but the point at which the line crosses the y-axis. That is y-intercept, and slope we know. So the slanting nature is called the slope. So we need to find b1 and b0 now. So that's our goal, to find the line of best fit. So this is the equation of b1. So b1 equation is the summation of x minus x bar. X bar and y bar are nothing but the mean value of x and y respectively. So how do we find the mean x bar? So we sum all the values of x and divided by the number of observation. The number of observation is 5 here. So because we have 5 values, the total value of x seems to be 15. 15 divided by 5 is nothing but 3. That is the x bar value, and y bar is 4. Why? Because like all the y values adds up to give 20. So 20 divided by 5 is 4. So now we have to find the product of x minus x bar and y minus y bar. So we have x bar with us, so it is easy now to find the x minus x bar. So 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, and 5 minus 3 is 2. Similarly, we will find the y minus y bar. 2 minus 4 is minus 2, 4 minus 4 is 0, 5 minus 4 is 1, 4 minus 4 is again 0, 5 minus 4 is 1. So now we need to understand the product. We need to find the product of x minus x bar and y minus y bar. So we have done in this column. Minus 2 into minus 2 is 4. 1 into minus 1 into 0 is 0. So 0 into 1 is 0 again. 1 into 0 is 0 again. 2 into 1 is 2 again. So we have found the sum to be 6. Similarly, for the denominator, we need to find the x minus x bar the whole square and find the summation. So we have x minus x bar in this column. We need to square them up, and we have found that here. So minus 2 square is 4, and minus 1 square is 1, 0 square is 0, 1 square is 1, and 2 square is 4. So we found the sum to be 10. So now we have found the slope. So slope seems to be 0.6. 6 divided by 10, that is 0.6. So B0 is calculated, and then B1 is calculated. So B0 is the intercept. So now to understand the intercept, the crux is that so we need to find the intercept. The intercept is nothing but the point at which the line crosses the y-axis. To find that, the assumption is that it's not the assumption. Sorry. So the line actually passes through the best line of fit will pass through exactly the mean point. So what is the mean coordinate? 3, 4. So that is the crux of finding the intercept. So we have x and y value coordinate to be 3 and 4. So now we have slope with us. So we just substitute them in this equation and find the B0, that is the y-intercept. So we have found that. So by substituting that, we get the y-intercept to be 2.2. So now our final regression line. So we call this as a regression line or line of best fit. It is ready. So now with this line, so we can substitute the unknown value of x. Say for example, I need to find the house rent of 2,500 square feet, for which I don't have here. So so for that I can input the values and predict the y values accordingly. So now, so after having done all this, we need to evaluate our model. So now our model is ready, but we have to evaluate it. How do we do that? So there is a method called standard error of the estimate. So this is the equation of the standard error estimate. The logic behind this is that we just need to, we have anyway the xy pairs for the actual values of y and the actual values of x and its corresponding actual values of y. What we can do is that we can again use a straight line and find how it gets deviated from the actual values. We have found the y cap, that is the predicted or estimated values for the given y. So by substituting the x value in this equation, we can predict the value of y again. So for x, it seems to be 2.8. When the actual value is 2, the estimated value is to be 2.8. So when x is 2, the estimated value of y seems to be 3.4 when the actual y is 4. Similarly, we have understood listed out the y values, predicted y values. Now we can find the distance. So y cap minus y. So what is the difference? What difference it throws? So that difference we have identified, y minus y bar or y cap minus y. So we have listed out in this column, and we have found their square, and the summation seems to be 2.4. So we have substituted those values in this equation. The square root of 2.4 divided by n minus 2. N is nothing but the number of observations. Number of observation is nothing but the number of values we have, that is nothing but 5. So an n minus 2. So when the n is large, this minus 2 can be omitted. So here it seems to be 0.89. So the error is actually fine because it's less than 1. It is acceptable. So that's how we find the error of the best line of fit we have formed. Okay, so now what we have seen is that we have seen today of how to come across, come up with a regression line which can be used to predict the values of the variables which have linear relationship between them. So that we do by means of finding the line of best fit using this equation. And we've also seen how to find the error of the line of best fit we have come across. Thank you.